Hello students, let's solve one of the examples based on this board, which is important for the board based on the application of derivative. We'll be doing solving one example based on application of a derivative there. So the question is that show that what is part here? Show that the height of cylinder of maximum volume that can be inscribed in a sphere of radius is 2r upon root 3 and also find the maximum volume. This is the question given here. So maybe one of the important question from the board point of view. So now let's go. Let's start. First, we have to while solving, we have to draw the figure of this. So I'll be taking a drawing a figure now directly for you here. Just going for a solution. If now this is the part here for the solution which we'll be finding in this case. So what is the figure now? If you observe this. So what are the parts here? See, this is your radius r. Let's go. This will be your center point, and this will be your the radius r capital R will be the radius of height of the cylinder, and h will be the radius, sorry, r will be the radius and h will be the height of cylinder, which is inscribed inside the sphere of radius r centimeter. So small r is radius of sphere, small r this one. This is the total height from here to here. This will be your total height what we are having here, and this r gives you the radius of the cylinder. Capital R is the radius of cylinder, h is the height, and as the center it is inscribed. This, if you'll observe these four corners, if you can observe, if I'll tell you this four corner, these four corners, if you'll consider, if you are taking and consider four corners, it the inscribed inside the cylinder is touching these four corners of the sphere. So as a result, what is happening? This becomes your center. This is your center point, and the radius r of the sphere is touching the center of the sphere, that is equal to height, half of the height of the cylinder. This is more important. Remember, this concept is very much important point of view. Just I'll remember, this is very important part. H upon 2, the part h upon 2 is very important. Height is half of that. So we'll be now solving further. Let's move. So let's go for further this part as this one. This is your according to the Pythagoras theorem. R square is equal to, I'll be taking this, R square is equal to h upon 2 whole square equals small r square, capital R square. So we'll be getting value of small r square equal minus h square upon 4. That is your step one. Now we have regular formula. We are learning three-dimensional geometry formula. Volume of a cylinder is pi r square h. So this r square, I'm substituting this r square value of r square in this formula of volume. So this in a terms of small r. So capital R in terms of small r. Remember, in terms of small r, small radius. Capital R is for the cylinder, and this small r is related to your sphere. Remember, this is for the small r means related to radius of sphere, radius of sphere. So we were finding on this way. Now pi into this r square, pi r square for direct is r, not r formula, it is r square formula. R square minus h square upon 4, that is h into h. So now expand that, r square minus h cube upon 3, h square upon 4. So as a result, h into h, that will become r square. Now what we'll be getting pi into r square minus h cube upon 4 there. Now here in this case, if we are taking a derivative of this, what we will be taking, we'll be considering a derivative of this part. Okay, just a minute. Now this h is going to multiply this. Here it should be r square h now. Sorry for not printed right in front. So it will become r square h minus h cube upon 4 there. So now we will be taking differentiation dv by dh. So pi is a constant taken outside, d by dh, r square h minus h whole cube upon minus 4. So differentiating this one, differentiating with respect to h, this h becomes 1, r square as it is, it will act as a constant here. 1 by 4 as a constant, 3 h cube will become 3 h square. The differentiation for h cube will become 3 h square there. So as finally we are getting pi r square into 1 minus 1/4 into 3h square, adjusting r square minus 3/4 h square there. So this is what we got in this case. Now let's go for a second differentiation for part. So how we are working here, just see. So for second differentiation, we are taking d2v, second d2v upon d square, pi constant as it is. We will be taking second differentiation of the first derivative that we got. Now in this case, what will happen now? With respect to dh, this r is going to act as a constant. This will become 0. Pi constant but taken outside the parenthesis or bracket there, they remain as it is. So for 0 minus 3 by 4. Now the derivative of h square is going to become 2h. So we'll be getting finally answer minus 3 upon 2 pi into h. Minus 3 by 2 pi into h. So if we are equating, next step now, we are equating this first differentiation to 0. If you are equating this to 0, pi gets cancelled, divide by pi on both sides. So you'll be getting r square minus 3 by 4 h square as a 0 here. Continued with this, will be getting 3 4 h square is equal to r square. So this is the h square r square term. R square in terms of h, or h square in terms of r square. We are continuing there. Now, in this case now, in this case, if you are continuing, I am taking h square equals to 4 r square upon 3. Just adjust it, cross multiply, and you'll be getting a final answer taking square roots on both sides. Square root on both sides there. On both sides there. So if this will become 2r, 3 will become root 3, h square will become h. H is greater than 0. So finally we are getting h is equal to 2 twice of radius divided by root 3. Now next, fine. This is the first part which was asked in our question. Show that height is equal to 2r upon root 3. Now let's go for second differentiation. Now the second differentiation, 3 by 2 pi into 2r upon root 3. Now for the second differentiation at h equals to r by 3, we are substituting this value in the volume formula, minus 3 by 2 pi. So it will become 2r upon root 3. This should be less than 0. If this is less than 0, V is maximum at h. This is max value. Remember. Because remember the sphere, the cylinder, is the cylinder inside the sphere, not going to cross any sections here. This will be your limits. These are the limits. More than that, the volume cannot increase. It is inscribed inside the sphere. So if we will substitute this 2r upon 3 from the first equation, what we had in this case, h equals from equation. Now what is the first equation? Just to remind, just I'll tell you, is r square minus h square by 4. We are substituting that value here. So we'll be getting h equals 2r upon root 3. So just from first equation, we are substituting that. We'll be getting 1 4 4 4 getting cancelled. R square minus r square by 3, that will be 2r square by 3. So volume of largest cylinder will be pi r square h, all in terms of small r. Pi 2r upon r square, that is your r square, multiplied by h. Remember, what is this? This is pi r square and h. So r square, we are substituting 2r square upon 3. Height, we are substituting 2r upon root 3. And finally, we are getting all in terms of small r, that is 4r cube upon 3 root 3 cubic centimeter. And this is what is finally they are expecting. This is what is expected in this case here. Okay. So this is what we are expecting here. So largest cylinder. So from this, what was the conclusion here? The volume of the largest cylinder of a inscribed inside sphere of radius r is 4r cube upon 3 root 3 cubic centimeter. Okay, thank you.